top of the hour, so we can go ahead and get started. So I'll just intro and then let James take it away. So this will be session 3 of our Gitaly training series. This meeting is being recorded and we'll publish it on GitLab Unfiltered. So James is a senior backend engineer on the Gitaly team, and he's going to talk about how does Gitaly fit into GitLab at like a high level. So without further ado, take it away, James. Oh, sorry. I wanted to make sure does everyone have access? Does everyone have access to the agenda doc within the calendar invite? Just put in the Zoom chat as well. So please put questions down if you have questions. If they're relevant to what James is talking about, I might stop him to have him clarify some things, or maybe we'll wait until the end of the session to answer them. So, all right, take it away, James.
So I'm just assuming that everyone can see my presentation, because otherwise.
Yep.
Sweet. All right. So
it.
hey, I'm James. I'm James Tiger, backend engineer. Like John already introduced me, and I want to talk about how Gitaly fits into GitLab. And I think one of the problems when you're trying to surf through our documentation to figure this out on your own is you kind of get two types of diagrams. You either get these architecture type of diagrams, or you get these kind of horrible timing diagrams. And the problem with these is they tend to have like a lot of Git terminology, and there's a lot of different components that are involved, and it's not necessarily obvious what they're responsible for or how Gitaly is even involved in this whole process. So I thought the way that I would go through this is by going through a few very common kind of request flows that involve Git and Gitaly. And as we go through these different types of requests, I'll be introducing other components of GitLab that are involved with how we do Git requests in Gitaly. And then I don't think any talk would really be complete about Gitaly without talking about Gitaly cluster just briefly. So just bring that up at the very end. So this is really like a basics overview for Gitaly and Git requests in general. So here we go. I thought I'd start off in hopefully the simplest way possible, and that is if you have just gone to the GitLab website and you're viewing the Gitaly repository, and it shows you this kind of directory listing here on the project page. So this is a pretty basic request. As I already said, you're kind of in your browser and it connects to GitLab Browse. I'm ignoring a lot of componentry here. For example, I'm ignoring all the reverse proxies that we might have for HTTP. And for GitLab Browse to build this response back to the browser, it will connect to Gitaly. Now, Gitaly is a gRPC service. That's how everything communicates to it. And in gRPC, the different RPCs are broken up into groups, and these groups are called services. So in this case, it's the commit service, and it's called get tree entries. Now, already we're kind of slipping into like this Git terminology hole. So if you think of a directory listing, that listing has lots of entries. Well, in Git, the way that we represent directories is with trees, and those files are Git tree entries. And the way that you get a tree object is that commits point to trees. So what we're really doing here is we're getting the head commit of the default branch, and from that commit we're getting the tree, and that tree has a bunch of entries in it, and that's our kind of directory listing for the project page. One thing that I think is important to know here is that Gitaly is just translating these RPC requests into a command that it runs. So what's really happening here is Rails is calling the RPC, Gitaly runs a Git command, and it parses the output of that command, and then that gets sent back to GitLab Rails, and then Rails generates the HTML or the API request response, and that goes back to the browser. So I think that's pretty basic start to how Gitaly is kind of hanging together, but it kind of gets more complex from here. So the next one I wanted to cover was Git clone over HTTP. Git has a couple of kind of protocols that it uses to transmit repository data to and from the server. There's smart and dumb. I'm only going to cover the smart protocol here just for simplicity's sake. Yeah, I'll just get onto it. Now, the smart HTTP protocol is broken up into two separate requests. And already I've introduced a new component here called workcourse. So workcourse, instead of before when I was saying that we connect to GitLab browse directly from the browser, well, that's not actually true. Instead, we connect to workcourse, which is kind of like a smart proxy. The idea of workcourse is that it can decide if it's offloading certain types of requests so that GitLab browse doesn't have to handle them. And those types of requests are typically GET requests or fetching objects from object storage. In any case, so this first request, we're just trying to get the list of refs for the repository that we're trying to clone. So this is a HTTP request to workcourse, and workcourse is going to do a couple of things here. The first one is that because workcourse doesn't know what the users are or what they're authorized to do, we have to quickly ask Rails. And so we do that by forwarding requests to Rails. It used to be that GitLab Rails would do all of the Git requests. That's no longer true. In fact, I don't even think it can anymore. It doesn't have the code to do that. So the way this happens is workcourse does this little HTTP request to Rails, and if Rails gives us the go-ahead, then we make a second call to Gitaly. Now, this is a different RPC, obviously. The service is called Smart HTTP Service, and the RPC itself is called info-refs upload pack. And so Gitaly is going to, again, run a git command and send those results back to git clone. And by the end of this first request, we should have the list of refs. But if you know about how Git repositories are constructed, then refs aren't really enough. You also need your object database. So we'll get that in the next part. The way that Git tends to transmit the object database is through a file called packs. And so the second request, we're going to request the pack. Now, similarly, it just makes another HTTP request, this time to a different path. It's not that important. I'm not going to go into details. And workcourse, because these HTTP requests are stateless, we need to ask Rails again if the user has permission to do this. So there's another request to Rails, and that just gives us the go-ahead. And then after that, we can make the actual call to Gitaly. This time, it's the same service, Smart HTTP service, but the RPC is called Post Upload Pack with side pack channel. Now, before, I was kind of lying to you when I was saying that workcourse connects over gRPC to Gitaly. One of the problems with gRPC is that it's not very good at transmitting a lot of data. It's good at transmitting kind of small structured data sets. But in this case, we're going to be transmitting basically an entire Git repo. That could be like gigabytes of data. So to save memory here, the problem with gRPC is that streams responses are made up of messages, and these messages have a size limit. So you build a message, and you add a bunch of data to it, and you send the message, and you make a new message, and add a bunch of data to it, and transmit it. Problem with that is it creates a lot of memory churn, and there's a lot of garbage collection that you end up having to do with that as well. So instead of connecting directly to gRPC, we use a kind of protocol called YAMX, or at least I think that's how you say it. I don't actually know. What YAMX is it's a connection multiplexer. So normally when you connect to gRPC, you'd make your TLS connection, and gRPC is like HTTP is like is encoded in the HTTP2 connection. So you're kind of making an HTTP2 connection with gRPC inside of it. Well, in this case, we do YAMX, and one of the multiplex streams on YAMX is this HTTP2 gRPC connection. And then when we call the special RPC, post upload the side channel, we create a side channel, but this side channel is actually just another YAML stream. And what this lets us do is kind of simplify the connection story between Workhorse and Gitaly, because we're only using this one TLS connection, but we have multiple different streams of data going through it. And what this lets us do is kind of connect the Git clone and the Gitaly. So remember, just like before, Gitaly is running a special Git command. In this case, it's upload pack. And then git clone is also running a Git command called git fetch pack. And what we want to do is connect them together as efficiently as possible. And we do that through this YAML stream. Yeah, I think that's that. Going through this too quickly, I think. Right. Yeah. Right. So this is kind of the same, but opposite. So we're this time, instead of trying to pull down all the repository data, we're trying to push up a little bit of repository data. And instead of HTTP, we do it over SSH. This is how we kind of would normally connect to the GitLab. So like push our changes, anything like that. Now we introduce another component here because none of Gitaly talks SSH. In fact, it doesn't even really talk HTTP either. It all happens through other services. So before we were using Workhorse to kind of do these authorization checks and then make the API call, or make the RPC call. But in this case, because we're doing SSH, so the git push will connect to the SSH server and then run this authorize key command. And the way and the project responsible for doing these authorized key checks is called GitLab shell. It's a separate repository from Gitaly. GitLab shell is kind of it determines all the things that you can do over SSH. So when you connect to an SSH server, GitLab shell are all the operations that you can run, and most of those are Git operations. So in this case, when you're connecting to the SSH server, it needs to the way that we correlate SSH connection to a specific user is we have to ask GitLab browse again, obviously because GitLab browse is where all our users are stored, so that's the only place we can do it. And you would have done this before, and when you're setting up your GitLab profile, you have to put in your SSH public key, and we use that to correlate to your user, and then in the future we can use that to check if you're authorized to push to this repo and things like that. So this is the first part. We check that your key is valid. And then we make this, and then the second part is we run that. So we're running this GitLab shell receive pack. Like I said, GitLab shell are like all the operations you can do over SSH. And again, this makes this basic like auth check with GitLab browse, and then it runs our gRPC RPC. In this case, it's called SSH receive pack on the SSH service. Now, git receive pack. So Gitaly is going to be running git receive pack, and then on the push side, it's git send pack. So for push and pull operations, you kind of have these tiers of git commands that you're connecting together, and all this infrastructure in between is just a way to get these two git commands talking in their own git protocol, if that makes sense. So before we had git fetch pack, git upload pack, and now we have git send pack, git receive pack. Yeah, I think that's it. Yeah. So that's pretty much all of the requests that I wanted to go through, and I did want to quickly bring up Gitaly cluster. So in an idealized world, because Gitaly cluster is works as a homogeneous, the way that GitLab browse should be treating Gitaly cluster is that it's just one big Gitaly instance. So anything past this load balancer here should really just be acting like a Gitaly server. You know, so you're connecting through YAMLs, or you're connecting through gRPC and making RPC calls. But where this kind of falls down in terms of like the entire GitLab architecture is that Gitaly makes connections. So if you're pushing through the load balancer and through maybe the primary prefect, and then and finally reverse proxy to a Gitaly, this Gitaly will be running that get receive pack command, and that get receive pack command might run hooks. Now, I didn't go into hooks here, but because I think it is probably an entire talk on its own. This is quite a lot to do with hooks, but this hook might end up, you know, talking back to GitLab browse to say, oh well, maybe you know, there's some new data, maybe you need to run some pipelines, or can you authorize this push to this branch, or like, is this a protected branch, or is this an invalid branch name, things like that. But where you are just sending normal Gitaly commands to the load balancer and receiving Gitaly data back, the individual Gitalys may be making connections outside of that back to workcourse. So even though you are only talking to the load balancer, maybe individual Gitalys talk outside of the load balancer. That makes sense. And that's all I wanted to talk about for that. And I think I went way too quick. It was supposed to be 20 minutes. Oh, well, 3 minutes off.
No, that was
yeah, cool.
great.
So,
Yeah. No, thank you, James.
That's my whole talk.
Yeah, so I think that was really helpful just to get an overview of that. So now's the time for any folks on the call, if you want James to maybe dig into any part of you know, the repo access or clones over HTTP or pushes over SSH, or maybe there's another area of Gitly that you have a question about. Let's keep it at like the kind of architecture of GitLab sort of level. Don't want to dig too deep into the technical details, but any questions like that or anything people want James to go over once more? I know.
Probably would be
Oh yeah,
interesting
go ahead, Demetra.
to dig a little bit more into the shell portion of it, because that's where like we got the overview, but it's a little bit murkier for me. Like HTTP is more familiar to me. Shell is not as
Yeah.
much.
Yeah. So basically, when you normally set up an SSH server and you SSH into it, you get dropped into probably like a bash terminal. This is like that, except that we have our own command that has like a limited subset of commands that it can run. The way that it's implemented as GitLab shell is just an executable, and it has a bunch of subcommands. I might be able to get this up, maybe. Well, if I can type. No. So in here, oh, no, that's on some command. So in here, so you can see the way the SSH server is configured is it has a custom authorized key check, and that points to this GitLab shell authorized key check command. But then all of the other commands go through GitLab shell. And if you look in here, oh, maybe not here, in here. Oops. There are a bunch of subcommands. And you can see there's maybe some other interesting stuff you can do, like LFS and two-factor. But in general, when you're pushing and pulling, there's receive back and upload back. And so basically what I'm saying is like this is the shell you get dropped into when you're SSHing into our server, and it has this limited subset of commands that you can do for the purposes of pushing and pulling from Git, but also maybe some of these other operations.
Right, so basically it's like all of the typical invocation when the Git does it to the remote server, we just implement the subset of those commands and they just talk into Gitaly and do
Yep.
whatever needs to be done. Okay.
Yeah, like I was saying before, like in a lot of these cases, we're really just trying to get the Git command on the client to connect to the Git command on the server, and Git has its own protocol that it's talking, but we need to give it kind of the stream to connect those two commands together. And that can happen over HTTP and it can happen over SSH with some minor differences, but yeah.
Cool, thanks. It made it clear.
Cool, thanks for that. I know, Tong, you had a question about this issue.
Yep.
Um, did you want to verbalize?
Yeah, sure. I'm curious what you think about this problem. So the short summary is that Geo is proxying both SSH and HTTP Git operations to Git HTTP. And there are differences between SSH and HTTP, right? And I don't know where this is the difference. But yeah, just curious what you think about this. Maybe you don't have the answer now, but yeah.
Yeah, don't want to put you on the spot, James. I just took a quick glance at this. I actually was not aware that this was happening in Geo.
I think, like I say, I mean, there are slight differences, but for the most part, all we're really interested in, at least from Gitaly's perspective, all we're really interested in is that the right RPC call gets made and that the right data is transmitted. So I guess that is an overall architecture problem. Yeah, I'm not sure.
Yeah, I mean, I'd have to dig into the history of how this decision was made in the first place. I'm assuming there were reasons for this, but I don't have that context.
Yeah, I think it might be interesting to dig more into it. But so the crux of the issue is that SSH supports deploy keys, HTTP does not.
Right.
Because I guess deploy keys is basically a public private key, right? How can you even authenticate with keys using HTTP? It doesn't work. So yeah. I guess that partly answers my question why are they different, but yeah. It's just this difference.
Good question.
Sweet.
All right. All right. Will anyone else have anything else? We have a little bit of time, but we don't need to stay on this call for too long. But yeah, maybe a few more seconds for anyone to bring up any parts of the presentation.
Right. I have a question. I don't know if it's a bit of scope from the presentation, but could you expand a little bit on how JAMOX and gRPC are used? I'm having a bit of trouble understanding. Like I've tried to understand gRPC in the past, and I think I got a hang of it. But how do you use JAMOX with RPC?
There is a page for this. Let me try to find it.
Thanks.
Yeah, side channel. So basically, hopefully this has a diagram. Yeah, so basically, instead of how we might normally create a connection to Gitaly using standard TCP, we use YAMX to create a session, and that makes the TCP connection for us. And then using YAMX, we create another connection within YAMX to create our gRPC connection. They're called YAMX streams. And you can create as many of these streams as you want. And what YAMX does is multiplex all of the messages of those TCP over that single TCP connection. And then for some of these special RPCs, these side channel RPCs, we create new YAMX streams and use that as like a raw TCP connection so that we can stream data faster. So we kind of sideline, it's called a side channel because we're kind of skipping out of gRPC and just using a raw connection instead. So in theory, these could all be separate TCP connections, right? Like you could just keep on making new TCP connections, like one for your gRPC and then another one for your side channel. But then that makes the firewall kind of stuff more difficult. Like you have to think harder about what ports you have open and how Gitaly and Workhorse interact. If we do it this way, then Workhorse connects to Gitaly's open port, like the one port, and we create this YAML session, and then we can create as many kind of fake TCP connections within that connection as we want. And without needing to have ports open on Workhorse to connect back or anything like that. Hopefully that answers the question. But yeah, here's the page. I'll put it in the notes.
Thanks. Yeah, I think I need to read more on it, but this definitely clarifies things a lot.
All right.
I guess just quickly, just to hang off that question, if that's all right. Yeah, so like, how does the gRPC get defined? I think I understand there's some sort of gem or something like that. The Gitaly gRPC gem.
Yeah, I think that's kind of in flux because we want to simplify it a bit. But basically, in GitLab repo, I can show you. We have our protos. This is like the canonical source of our gRPC definitions. So we can go to Smart HTTP, which I talked about earlier. And here's all the RPCs and how they're defined. And if you go further down, here's the requests and responses. For the gem, there's a we have to manually run a publish. It's not done automatically. I think there's a Slack command to do it. And that builds the gem separately. But I think we want to simplify this process somewhat, but it hasn't happened yet.
I think we have a make target to build a gem and then
I can try to find that. It's probably not in this repo though, is it? Oh yeah, it is. Yeah, this is how we do it.
And then we publish it to Ruby gem.
And then we put the gem in bundler for the Rails app, right? And then that's how so the Rails app knows.
Yeah, and then GitLab Rails has a lot of other code supporting code that tries to make some kind of abstractions around that with more or less success. Yes.
Yeah, good question, Tom. All right, any other questions for James? Going once, going twice. Robert, are you unmuted? Do you have a question?
Oh no, I thought we were just saying goodbye. I was just nothing.
Okay. Yeah. Yeah, great. All right. So yeah, thanks everyone for joining. I want to thank James for the presentation. I think it was a great high level overview of how Gitaly fits into the rest of GitLab. I'll go ahead and publish this onto GitLab Unfiltered probably tomorrow, and I'll send it out so in case you want to rewatch the recording. All right. Thanks, everyone. Have a good day. Bye.
Bye.
Thanks. Thank you, James. Bye.
Bye.